Here's another range of products that depend upon the amazing properties of plastic for their success. What are they? Vacuum cleaners with a revolutionary design.
I realised there was an inherent problem with a bag vacuum cleaner because it clogged and blocked the airflow. So I looked around for a system that didn't have that problem, and I discovered a thing called a cyclone. These are 10 metres tall and they sit on the top of sawmills. And the eureka moment really was realising that a cyclone can separate the dust and dirt without putting anything in the way of the air. The look of the product derives from the engineering and the function of the product, what it's doing. And because our product, our vacuum cleaner, works differently to other vacuum cleaners, naturally it looks different, and we encourage that. We use colour to highlight the things you have to touch or deal with, or things that are important for the function. So for example, the cyclone we very often highlight in a different colour because that is the essential difference between our product and other people's products. So we want to draw attention to that. And things like catches and switches and buttons and dials and all those sort of things, we always make those a contrasting colour so they're easy to find.
James Dyson's company now has 18 different models on the market. The quest is on to design a new, more compact machine for Japan, and Alex is the man with the mission.
At the beginning of the process, we create a brief which succinctly describes what we're actually going to manufacture. So it'll be a small, powerful cylinder vacuum cleaner using dual cyclone technology.
Alex uses a variety of different prototyping techniques to perfect his design.
We start making things in 3 dimensions very quickly, and we use cardboard and hot melt glue, and we develop a number of different schemes. We choose one, and we start developing the product from that. The next thing we do is to build what we call a breadboard prototype. This doesn't look very much like the final thing, but again, it has all the key elements in, and it actually works. So that means at a very early stage, we can start testing and evaluating and developing the product in terms of its performance. And also, we look at other details. So for example, as we're developing an on-off switch, we'd make a small prototype of that and prove that it works. Another area we would develop carefully would be the catches, or the way the product opens and closes. As the design develops, the details get more and more resolved on our CAD system, and we can make further breadboard models using rapid prototyping techniques. So directly from our 3-dimensional data on the CAD system, we can download that to the rapid prototyping machine, and the next morning we come back and there is a plastic component which we can then use to evaluate, to show to people, and just to double check that the detailed design we've done on the computer actually works and gives us exactly what we want.
An exploded view shows all the constituent parts. This helps engineers assess the cost and technicalities of manufacture.
When we're happy with the prototype and we've finalised the design, then we can order the injection mould tooling. This is the tool for the cyclone top component.
The top is just one of 75 parts that go together on Dyson's assembly line to make the final machine. Precision moulding means that the parts all fit together perfectly and house the wiring and motors. 8,000 vacuum cleaners roll out of this factory each day. Many of them end up cleaning far distant corners of the world.